Okay, hello everyone. Welcome to week 5, and so we're going to take a look at categorical propositions for this week's lecture. So let me preface this a little bit. This week will be a building phase for what we're going to do next week. So these categorical propositions that we're going to try to understand in this lecture, we're going to use all of these concepts combined with stuff next week to be able to actually analyze and evaluate arguments for validity and invalidity. So it's important, although this stuff seems sort of abstract and not particularly relevant to critical thinking, the stuff in this section or these concepts are important for being able to do something later on. So take it seriously, and it shouldn't be too complex. Okay, so first let's talk about categorical propositions. These are propositions, and the word proposition, you can think of that as meaning a statement. Like a declarative sentence, in other words. So categorical propositions are propositions that are the building blocks for categorical syllogisms. So you use these statements or propositions to build syllogistic arguments. Now, we'll learn about syllogisms next week, but a syllogism is just an argument, deductive argument, has two premises and one conclusion. And so you can build deductive arguments out of these propositions that we're going to look at in this chapter or this section. So what they do, every categorical proposition, it relates a subject term and a predicate term, and either all or part of the class denoted by the subject term is included or excluded from the class denoted by the predicate term. Now that's just fancy language, and all that really means is that whatever is asserted in the subject is either asserting or denying something that's in the predicate slot of the proposition. So let's look at these in this chart just briefly here, and we're going to see them in more detail as we go along. But you have an all S or P type proposition. You have a no S or P type proposition, a some S or P type proposition, and some S's are not P type proposition. So what those mean, if we translate those into clear language, all S's or P's means that every member of the S class is a member of the P class. That's what it means. So every member of the S class is a member of the P class. So you could stick something like dogs and mammals in there for S and P. So you could say all dogs are mammals. So you're making a claim that everything that is a dog is also a member of the mammal class. Okay, so moving to the next one, no S's or P's, that just means that no member of the S class is a member of the P class. So using dogs and mammals again, if we asserted no dogs are mammals, that means that not a single dog belongs in the class of things we call mammals, which would be false, obviously, but it's still, you understand the assertion there. And then moving to the third proposition, some S's or P's, that means literally that at least one member of the S class is a member of the P class. So if we said some dogs are mammals, that would mean there's at least one dog that is a member of the mammal class. And then finally, some S's are not P's. At least one member of the S class is not a member of the P class. So some dogs are not mammals, which would mean that there is at least one dog that's not a mammal. Okay, so also, and I'll bring this up a couple times here, but the R in the all S's or P's and the no S's or P's and the some S's or P's and the R not, that's referred to as the copula. So we're going to learn all the parts of these propositions, and that sounds like it's not particularly important, but later on it will be important when we evaluate categorical syllogisms next week. Okay, so the connecting word here, R or R not, that's referred to as the copula. C-O-P-U-L-A. But it'll come up again here in a second. Okay, so there's a standard form for categorical propositions. So the propositions that we just looked at, all S's are P, no S's are P, some S's are P, and some S's are not P, they have to be put into a standard form in order for us to be able to evaluate them in arguments. So the standard form requirements are that you have to have a quantifier of all, no, or some. So a quantifier is just that first word that tells us how many things we're dealing with. All, no, or some. All dogs are mammals, it tells us that we're dealing with every single member of the dog class. No dogs are mammals, it tells us that we're dealing with every single member of the dog class also. And some dogs are mammals tells us that we're dealing with at least one member of the dog class. So the quantifier is just that first word, all, no, or some. The subject term is a noun or a noun phrase, so that's the word or words that come right after the quantifier. So in all dogs are mammals, dogs would be the subject term. The copula, or the link between the subject and the predicate terms, those are always are or are not. So I told you this in the other slide. All dogs are mammals. All is the quantifier. Dogs is the subject term, and the copula is are. And then finally, the predicate term is the noun or noun phrase that comes at the end of the proposition. And so in that case, it would just be the word mammals. All dogs are mammals. The predicate term would be mammals. So to be in standard form, a categorical proposition has to meet all of these requirements. It has to have a quantifier, all, no, or some. Has to have a subject term as a noun or a noun phrase, has to have the copula are or are not, and there must be a predicate term as a noun or noun phrase. And by the way, just to understand why they're called categorical propositions, what they do is they relate categories of things. So if we say all dogs are mammals, we're relating the category of all things that are dogs to the category of all things that are mammals, and that's why they're called categorical propositions. Okay, so moving to the next slide. Let's talk about quality, quantity, and distribution. So when we use the term quality in relation to categorical propositions, it's either going to be affirmative or negative, and this is super easy. So the categorical propositions all S or P and some S or P are considered to be an affirmative quality because they're asserting something positively. They're saying all S's are members of the P class, or some S's are members of the P class. On the other hand, categorical propositions no S's are P and some S's are not P are considered to be negative quality because they're denying something. They're in the first case they're denying that not a single S is, what they're asserting is that not a single S is a member of the P class. And in the second case, there's at least one S that's not a member of the P class. So they're negative here because they're denying something, and they're affirmative here because they're asserting something positively. And so this is easy to remember. If you see a no or an are not, it's going to be negative. Otherwise, it's going to be affirmative. Okay, so you need to know the quality of any categorical proposition that you're given. And then quantity, that's easy. We're talking about the quantifier here. That's just the word that's at the very beginning of the proposition. So the quantity for an all S or P proposition, that's universal because it's making a claim about every member of the S class. And the quantity for a no S or P proposition, that's also universal because it's making a claim about every member of the S class and every member of the P class in that case. So the quantity is universal for all S's or P and no S's or P. Universal because we're asserting something about every member of either the subject class or the predicate class or both. Subject being the first term here and the predicate being the second term. Okay, then you have particular quantity. Those are the categorical propositions that start with the quantifier some. So some S or P, that's particular, and some S or not P, that's particular quantity. So this one's easy too. If it's some, it's particular. If it's anything else, it's going to be universal. Okay, so the letter names of propositions. Since the Middle Ages, logicians have assigned the vowels A, E, I, O to refer as shorthand to these 4 different types of categorical propositions that are in standard form. So that means that if I say an A-form categorical proposition, what that means is a categorical proposition that has the form all S's or P's. If I say an E-form categorical proposition, what that means is a categorical proposition that has the form no S's or P's. I represents some S's or P's, and O represents some S's or not P's. So this was just a short way for logicians in the Middle Ages to talk about these propositions. Instead of having to state the entire proposition all S's or P, they could just say the letter A. And you could construct arguments, we'll see this next week, just using letters. You could just say an AAA argument or an EIO argument, an AEI argument, and so you could easily, using this shorthand, state fairly complex arguments. Okay. And then finally we have distribution. This is a little more complicated, but it's really important to understand distribution because we'll be using it next week to determine whether arguments are valid or invalid. So distribution applies to terms, not to entire propositions. That means that when we're talking about something being distributed, we're talking about either the S or the P itself in the proposition. We're not talking about the entire proposition itself. S could be distributed, P could be distributed, but the entire proposition would never be distributed. So what does it mean for a term to be distributed? A term is distributed if something is asserted about every member of the class of things denoted. So if there's a claim being made about every member of the S class or the P class, then we would say S or P is distributed in that instance. So let's look at these 4 standard form categorical propositions, A, E, I, and O, and understand which terms are distributed in each of them individually. So if we're dealing with an A-form proposition, all S's or P's, the S term is distributed. And that's pretty easy to see if you think about it. If I say something like all dogs are mammals, I'm making a claim about every member of the dog class, but I'm not making a claim about every member of the mammal class. So when I say all dogs are mammals, I am saying something about all dogs, but I'm not saying something about all mammals. So that's why just the S term is distributed in an A-form proposition, all S's or P's. Okay, moving to an E-form proposition, no S's or P's. Both the S term and the P term are distributed. So what that means is that when you put a no quantifier on front of a categorical proposition, you are going to end up asserting something about every member of the S class and every member of the P class. So let's stick in dogs or mammals, and I think it becomes a little more obvious. So if we say no dogs are mammals, we're clearly saying something about every member of the dog class, and we're saying something about every member of the mammal class. Those things never overlap if we say no dogs are mammals. No dog is ever in the mammal class, and no mammal is ever a dog. Okay, so for an E-form proposition, no S's or P's, both S and P are distributed. For an I-form proposition, this one's easy. Some S's or P's, neither S or P are distributed. Neither S nor P are distributed. So that's pretty easy to see. If I say some, then I'm not talking about every member of any class. I'm saying some, stick in dogs and mammals, some dogs are mammals. I'm saying something about at least one dog, but I'm not saying anything about every single dog, and I'm certainly not saying everything about every mammal if I'm saying some dogs are mammals. Not every mammal is a dog, obviously. So in an I-form proposition, neither the S nor the P are distributed. And then finally, with an O-form proposition, some S's are not P's. Only the P term is distributed. So if you add the copula are not, remember the copula is the word or 2 words here in this case that connects the subject and the predicate terms. If you add the copula are not, some S's are not P, that makes the predicate term distributed. That's the P in this case. So if you say some dogs are not mammals, you wouldn't be saying something about every member of the S class, but you would be saying something about every member of the mammal class. So it's important that you remember what terms are distributed and what terms aren't. In an A-form proposition, the predicate is not distributed and the subject is distributed, so the S is distributed in this case. In an E-form proposition, both S and P are distributed. In an I-form proposition, neither S nor P are distributed. And in an O-form proposition, only the P is distributed. The S is not distributed. Okay, so here's a summary of everything we've done on these slides through 4.1 and 4.2. It's important that you know all of the stuff on this chart. You have to understand it really well to be able to apply it in the context of categorical syllogisms, of arguments that we're going to look at next week. So if we're dealing with an A-form proposition here, all S's are P's, the quantity is universal because we're making a claim about every member of the S class. The quality is affirmative because there's not a no in there anywhere. There's nothing negative. And the term S is distributed. If we're looking at an E-form proposition, no S's or P's. The quantity is universal. We're making a claim about every member of the S class and the P class. The quality is negative because there is a no there. And the distribution is S and P. Both the S term and the P term are distributed. Something's claimed about both the S and the P term, in other words, about every member. Then we look at an I-form proposition. Some S's are P's. The quantity is particular because we're only talking about at least one. Some is not a universal quantifier. The quality is affirmative because there's no in there anywhere. There's nothing negative. And note there's no distribution in an I-form proposition. Neither the S nor the P are distributed. And then finally, some S's are not P's. This is our O-form proposition. The quantity is particular because we're still just talking about a single member of the S class. The quality is negative because there's a not in the copula. There's a no there. And the P term is distributed. There is a claim being made about every member of the predicate class or predicate slot in the proposition. Okay, so like I said, these are the things you really need to know to be able to navigate what we're going to do next week. So burn these into your brain, take them seriously, because if you don't understand these basic things and have them essentially memorized, it'll be harder to navigate what's going on in week 7. I guess that'd be week 7 for us. Okay, so let's learn next about translating ordinary language statements into categorical form. So we looked at the categorical propositions in standard form. All S's are P, no S's are P, some S's are P, and some S's are not P. The problem is, in everyday language, most of the time, propositions of that sort are not in standard form. So the goal here, in the end, would be able to take ordinary language statements, translate them into standard form categorical propositions, construct arguments using those categorical form propositions, and then be able to tell whether the arguments are valid or invalid using certain rules that we'll learn next week. That's the end goal. So for week 7, I'm going to ask you to translate ordinary language statements into standard categorical form, put those into standard syllogistic form, which we'll learn next week, and then determine whether they're valid or invalid. At least that'll be one of the tasks I'll ask you to do. Okay, so let's look at the basic idea behind translating ordinary language. So you run into terms without nouns sometimes in ordinary language. So if a term consists of only an adjective and a plural noun or pronoun, if a term consists only of an adjective, a plural noun or pronoun should be introduced to make the term genuinely denotative. So what does that mean? It's fancy language, but it means something fairly simple. If we're given the term of the proposition, some roses are red, that's not standard form because the predicate position here, red, has to refer to an object. It has to denote an object. And so it does in the subject slot. Roses are objects, but the predicate slot is just the adjective red. And so in order to put it into standard form, you would simply translate it into some roses are red flowers. Or you could say red things or red objects. But the goal here is to make sure that you're actually dealing with a noun. Both the subject and the predicate have to be a noun or a noun phrase. They have to refer to an object, and red is a property of an object. It's not actually an object itself. Okay, so you translate statements that lack a noun and only have an adjective there into some kind of noun phrase. So in this case, it's translated as red flowers or red things or red objects. Okay, so that's terms without nouns. Then you have non-standard verbs. So statements in ordinary usage often incorporate forms of the verb to be rather than are and are not. So for the first statement here, some college students will become educated. That's not in standard form because we don't have an are or are not as a copula. But we can translate that will become into some college students are people who will become educated. So we're just moving the will become into the predicate position and putting the copula are there. So there are a number of ways you could do this. You could say some college students are people who are things that will become educated. Some college students are objects that will become educated. In any of those instances, you've translated it into standard form because you have a genuine noun phrase. You have to have a copula, either are or not, and it has to be a genuine noun phrase in the subject and predicate terms. Okay, so that's non-standard verbs. Then you have singular propositions and the use of parameters. So this proposition makes an assertion about a specific noun, while the parameter affects the form, not the meaning. And so when we're talking about the word parameter here, we just mean things like people identical to. It delineates a boundary for an object. Right, so if we're starting with a sentence, this is a singular proposition. It just says George went home. Right, that's not in standard form. Obviously, it has to be in the form of proper quantifier at the front and a copula in the middle, and so on. So George went home could be translated into all people identical to George. Identical to George is people identical to George is the parameter. Are people who went home. So remember, the goal here is simply to get it in a form that matches the basic requirements of having a quantifier and a copula and a noun phrase in both the subject and predicate term. So you can do that a lot of different ways. In this case, I've chosen to put people identical to George, but it could say all things identical to George, are things who went home, all objects, and so on. You can use a number of different types of nouns there. But the whole goal is to make it look like a standard form categorical proposition. Adverbs and pronouns. So spatial and temporal adverbs may be respectively translated in terms of places and times. And so he is always clean shaven. It's clearly not in standard form. And so we have to deal with this time aspect here. Always. And so you could translate that as all times are times he is clean shaven. So always becomes times. Our copula is are, and so we have a noun phrase here, or a noun times, and then we have a noun phrase, a noun with an adjective here in the predicate slot. So I know these can get a little complicated looking, but if you just sit and think about it, it becomes easy to figure out how to translate ordinary language into these other forms. And when I give you examples on the quizzes, I will give you fairly straightforward and easy examples. They won't be really, really complex ordinary language statements. That takes a lot of practice. I don't expect you to be absolute experts at translating these things with a week or so of study. But you should be able to handle translating fairly simple statements. And then we have unexpressed quantifiers. So remember, the quantifier is the word that's on the front, all, no, or some. And sometimes statements will lack a quantifier, but there's an implied quantifier. So you want to be guided by the most probable quantifier. You have to look at the context and so on. But so if you get a statement of something like emeralds are green gems, that seems that the initial statement is making a claim about every emerald that exists or ever will exist. And so the most accurate translation of that into standard form would be all emeralds are green gems. You're making a claim about every member of the emerald class. And so, sorry, skipped the wrong slide, so go back here. So if we move to one that uses a particular quantifier, there are lions in the zoo. Now that's not in standard form, obviously. It's got to be all S's are P, no S's are P, some S's are P, and some S's are not P. It's got to be one of those. And so there are lions in the zoo. We are not making a claim about every single lion. We are simply making a claim about just the lions in the zoo. So we would translate that some lions are animals in the zoo. So it meets standard form. You have the noun in the subject slot, R is the copula, and noun phrase animals in the zoo as the predicate position. Okay, so those are fairly simple. You know, when you see words, when you see statements that lack a quantifier, it's usually pretty easy to figure out whether it should be all, no, or some. And then non-standard quantifiers, all, some, or no. So a non-standard quantifier, you know, you got to change it into something that's standard, into the all, no, or some version. So if you see something like a few, or many, or a bunch, or a lot of, those are not making a claim about every single member of a particular class of things. So those would always be translated as some. So in this example, a few soldiers are heroes. We're not making a claim about all soldiers there. We're making a claim about just at least one in that case. So the standard quantifier form would be some soldiers are heroic. Or you could, you know, heroic is one way to do it here, or you could say some soldiers are heroic things, or things that are heroic. Any of those things, those noun phrases would be accurate translations. You know, it doesn't have to be perfect in the translation, other than that it matches the standard form and conveys the essence of the original proposition. So in this case, I've changed heroes to heroic. Those are different words, but it still conveys, it's in standard form, and it conveys the essential meaning of the original proposition, a few soldiers are heroes. Conditional statements. So conditional statements are just if-then statements. That's what conditional means. If A, then B. So if it's a mouse, then it's a mammal. That would translate into all mice are mammals. Conditional statements are always translated as universal in their quantifier. Conditionals are always claims about every member of a given class. So if we're saying if it's a mouse, then it's a mammal, we're saying everything that's a mouse must be a mammal. So you're making a claim about every member of the mouse class. Not a claim about every member of the mammal class, but certainly a claim about every member of the mouse class. So all mice are mammals would be the accurate translation of if it's a mouse, then it's a mammal. If it's a turkey, then it's not a mammal. We're making a claim about every single turkey, and we're making a claim about every single mammal. So the only way we could translate that accurately would be to use the quantifier no. And so no turkeys are mammals, because we'd be making a claim about every member of the turkey class and every member of the mammal class. So remember, conditional statements are always translated in universal form, either an all or no quantifier. And then finally, we have exclusive propositions: only, none but, none except. And these can be really tricky to translate, and I won't throw you any real curveballs on the quiz, the graded quiz particularly on this kind of stuff. But if you see something like none but the brave deserve the fair, you know, this sort of exclusive proposition, excluding certain members from the class of things that deserve fairness, right? So that would be translated as all people who deserve the fair are brave people. So none but, the none commits us to a claim about every member of that particular class. So we're saying something about every member of the class of people who deserve fair treatment. And so you have to use the quantifier all in that case. Okay, so that sort of gives us a basic idea of how to translate ordinary language. And I don't expect, like as I said before, I don't expect you to be experts at this after just a few examples. There are a lot of practice exercises in the textbook on this translation stuff at the end of chapter 4.7. I suggest you work through those. The starred answers are in the back of the book. So work the starred questions, and then you can actually look back and see how close your translation was. Okay, so if you have any concerns about this, don't hesitate to message me, but work through this as best you can, and I'll have some practice quizzes in there for you to get ready for the graded quiz in this material. See you guys next week for categorical syllogisms in week 7.